this video, we're going to talk about mappings in Solidity. A mapping is a key-value data structure. Similar to a dictionary, you provide a key, and Solidity gives you the value associated with that key. Mappings are one of the most important and widely used data structures in Solidity, especially when you need fast lookups by address or by ID. A basic mapping declaration looks like this. Here, the key is an address, and the value is a uint 256. You can read it as, for every address, store a numeric balance. Mappings can only exist in storage. They cannot be created in memory or passed as function parameters. To write a value, you use the key in square brackets. To read it, same idea. Mappings provide constant time access, O1, making them very efficient for direct reads and writes. This is exactly why mappings are so common in token contracts and permission systems. They're simple and efficient for direct access. The key type must be a value type, such as address, uint 256, bytes 32, or bool. The value type can be almost anything, including basic types, structs, arrays, and even another mapping. For example, mapping an address to a struct. One behavior you should always remember is this. If a key was never written before, Solidity still returns a value, but it returns the default value of that type. For uint 256, that default is 0. For bool, it is false. For address, it is address idents 0. So if balances user returns 0, you cannot distinguish between a value that was never set and a value explicitly set to 0. If you need to tell those two cases apart, you must add extra tracking logic. Mappings can also be nested. A very common example is ERC20 allowances, to read a value. In this pattern, allowances owner spender returns how much spender can spend on behalf of owner. A key limitation of mappings is that you cannot iterate over them directly in Solidity. Mappings are not iterable and do not store keys, only values associated with keys. There is no built-in way to retrieve all keys from a mapping. If you need iteration, you usually keep a separate array of keys. Using a dedicated is-known mapping avoids duplicate keys in a count list. Mappings are efficient for direct reads and writes because access is done by key in constant time. However, if you introduce arrays to enable iteration, gas usage increases with the size of the array, especially inside loops. If the list grows too large, iterating over it in a single transaction can make your function expensive or even unusable. Because of this, iteration patterns should be used carefully and only when necessary. Mappings are a core Solidity tool for storing and retrieving data by key. They are ideal for balances, permissions, ownership records, and many other contract patterns. The two most important rules to remember are: mappings return default values for missing keys. Mappings cannot be iterated directly. Once you understand these rules, mappings become one of the most reliable and practical structures in smart contract development.